we're going to take that exactly away, start looking at bigger things. And so again, that's kind of where, look at 4C there. It says no more than once, no more than 1, 1. Part D there, no more than 3 ones. So start adding phrasing like that into the problems. Okay. And we are also going to look at a different experiment than we've talked about before here, so just a spinner. Okay? So we've talked about rolling die, we've talked about drawing cards, talked about flipping coins, okay? Drawing marbles, stuff like that. But here's just a new contest, a spinner. Right? So just like Twister, just like the little thing on life, right? Just a spinner. But it's got 20 sections on it, and numbered 1 through 20. To win, you have to land on a multiple of 4. And we're spinning it 5 times. Okay, so there's our game. Got a spinner. Win if you land on multiple 4. You get 5 spins. Okay, so what's the probability that you win 0 times? Okay. So what are the 3 things we need to know? Is that? NERP. NERP. Yep, we need to know NERP. Okay. So what's N stand for? Right? Anytime we look at a formula, we have to know what the letters stand for. What's N stand for? Number of trials. So how many trials we got here, Colby? 5 trials. Okay. We got 5 spins. N is 5. What's R stand for? So number of successes. How many times are we being asked to be successful here? 0 times. They want 0 successes. What's the probability that you are not successful at all? Okay, you never win. So our R value is 0. And then what is that probability of 1 time? All right, you spin it once. What's the probability that you win? So where does that come from? Where does this probability come from? Remember, usually R and N are stated. You have to figure out P, usually. What's the probability of winning? 1 out of 20? Why is it 1 out of 20? Okay, so the spinner contains 1 out of 20. What aren't you taking account of, though, Andrew? How do you win? So what are the multiples of 4? What are the multiples of 4? 4, 8, 12, 16, 20. Yeah. So what's our probability? How many ways can we win? No, not how many times are we going to win. How many ways can we win? Five out of how many total things could happen? 1. So 5 out of 20 or 1 out of 4. 4.25. Okay. You decide how you want to write that. If you want to write it as a fraction, if you want to write it as a decimal, you decide. But if it's a non-terminating decimal, if it's not 0.25, if it's not 0.6, and not 0.75, okay, if it's 0.33333, you can't do that. You have to leave it as a fraction. Okay. Do not turn decimals that don't stop don't take fractions that don't stop and turn them into decimals. So, of course, we have our formula, n factorial over n minus r factorial times r factorial times 2 to the r. Do you need something, Maddie?
Yeah, I just don't know why the probability is what we would need to win. We're not really trying to win. Like, why isn't the probability 3/4?
Okay, that would be the probability of not winning, right? So we'd have to change the question. That's a good question. We want to see what's the probability of not winning, right? We get 5 spins. What's the probability that on none of those spins we win, right? So we could change the question and say, well, what's the probability of not winning all 5 times? right?
I was just looking at the wrong part of the question. I get it now.
Yeah, but that's certainly a valid question, right? We could also do that math. What's the probability of not winning 5 times? Would be the same as the probability of winning 0 times. So yeah. Okay. So we've got all those. We've got our 3 values. We've got our formula, right? And the rest is just being really careful about typing. Okay. I had a student in second hour typed. I think we were doing part B at the time, but they put a minus sign here, and they got an answer that was really, really close to what it should have been. It was only like 2% off. But if I hadn't known what the answer was and been walking around checking, there would have been no way to know that. All right. So it's your guys' responsibility as you type it in to like go back and double check. Did it actually get typed in right? Because it's so easy to mistype something when you're doing this. All right. So just be really careful about it. And again, with this 0, we could actually do most of this in our head if we wanted to. There's very little that you would actually need to do in a calculator when you have that 0 there. So when you look at this part of it here, 5 factorial divided by 5 factorial, that's just 1. 0 factorial is also 1. And 1/4 to the 0 power is also 1. So the only thing that we actually have to type into our calculator is what 3/4 to the 5th power is. That should give you the same answer as all the typing that you did. Okay? So what's 3/4 to the 5th power? Again, I'm asking you guys to keep 3 decimal places, turn that into a percent, like 1/10 of a percent. So 19.2% or whatever. So what's that give us? 3/4 to the 5th. What do you Matt?
You said about the nearest time.
Keep 3 places because then we'll turn that into a percentage with a 10th. Okay. So we'd say that's 23.7%. Yeah. So about a 1/4% chance, right, that we wouldn't win at all. Right? Spinning it 5 times, that none of them would win. 25% chance. Okay. So what if we win exactly once? That doesn't mean we win 0 times or 1 time. It's exactly once. So that means we win once, 4 times we don't win. Okay. So that word there is very important. Is exactly we win once, the other 4 times are losses. Well, our number of trials doesn't change. Our probability doesn't change. One thing that's changing is R. Okay. So what happens when we go through and change R, right? And so think about if you typed the last one in, can you go back and edit it? So you just change all those 0s to 1s. Can you do that? Or, is there a way that you could go and type this and have to type the full thing back out? Right? Is there a way you can edit the last one, depending on what you typed in? Okay. Doing what I did because I did all that canceling, I can't do that. I have to retype, I have to start over, but again, make sure you're hitting those hidden parentheses that aren't in the formula. That if you're typing it exactly like this, those things need to be there. And as silly as it seems, like you guys sitting here and doing all of these over and over again with me, with us, just getting that little bit of practice is going to really reduce the chance that you make a mistake when you're doing it on your own. You're going to start to see where the little places where you have made mistakes, and you're going to start being a little more careful there. Sorry, what? 3955?
Yes.
You should be getting like 0.3955. So rounding that, 39.6%. Okay. And just one more here. Okay, promise there's a purpose for us doing this over and over again. So n is 5, p is 1/6. What's the probability that we win exactly twice? So it means you win twice. The other 3 are losses. Okay. You spin it 5 times. 2 times you land on a multiple 4. The other 3 times you do not land on a multiple 4. So just changing that r value to 2 now. Okay. Yep. I don't know. What, 1/6? What are you talking about, 1/6? I don't know. Oh, okay. Yes, because I'm silly. Thank you. Because I got dice on the brain, apparently. Yeah. Okay. So yeah, can you just take the last thing you typed in and edit it? You know how to do that, so you don't have to retype all of that over and over again. All right. So change all those 1s to 2s. You find it, Katie? You can make sure those extra parentheses are there if you need them. I'm getting 0.2636-ish. So it'd be 264. So it's kind of interesting to see how the probability changes, like from just 1 win to 2 wins or no wins. But really the point of doing this was to get to the part where you can look at the next problem, part D. Okay? And so much of this stuff, guys, like, we're having to do a little bit of math here. Most of the math is being handled by the calculator. We had to figure out a probability. But most of it's just reading, okay? And so it really comes down to so much when you look at this, do you actually understand what you're being asked to find? Okay? What's the probability of winning at most twice? And so that change of the phrasing there is super important. So not winning exactly twice, which means win 2 times, lose 3 times. But to win at most twice. What does that mean? If you win the game at most twice, what does that mean? What does that mean, Matt? You said can lose win? Loose win?
What I meant was you can either lose, win once, or win twice, and still.
So instead of saying lose, what did you mean?
Get 0 wins.
Huh? I didn't hear.
Get 0 wins.
Yeah, you can get 0 wins, you can get 1 win, or you can get 2 wins. Right? To win at most twice means you win 0 times, you win 1 time, or you win 2 times. That's okay. But it's this word or that matters a lot here. I can do this, or I could do this, or I could do this. So how do we figure that out? How does that word or become important here? What's that word or telling us to do mathematically? You're rolling a die. What's the probability that you roll a 1? 1 out of 6. What's the probability you roll a 2? 1 out of 6. What's the probability you roll a 3? 1 out of 6. What's the probability that you roll a 1 or a 2 or a 3? 3 out of 6. Because you can get 3 things out of 6 total things. How do you take 1/6 and 1/6 and 1/6 and get 3/6? What do? Math. Add. The word or means add. Okay? We can see that. The word or means to add in this context. So if we can win 0 times or 1 time or 2 times, then we need to add. Okay? Am I being clear here, guys? This is important. Okay? This orness is really important. Okay? We can do one thing or another, start getting a whole lot more probable. Okay? What's the probability of flipping a heads or a tails? Ooh, got a lot easier to win, right? The or changes things a lot. So we need to take that probability of winning 0 times, which we calculated. Okay? So the 23.7 and the probability of winning once, 39.6, and the probability of winning twice of 26.4. We need to add those up. What do we get? Any clear? So probability of 89.7% of winning at most twice. That was so dependent on us understanding this phrase. Okay? So you start including multiple probabilities in this situation. Okay? So watch. So if it says, what's the probability of winning twice? It says what's the probability of winning 3 times? Probability of doing this 5 times. The implied thing there is that it means exactly. Okay? If it doesn't say exactly, because I forgot to write the word, that was the implication. Okay? If it's at most twice, at least 5 times, no more than 7 times, that phrase has to be there. You can't imply that. Okay? So if anything's left out, it would be the exactly. I would try not to do that, but That's most likely what I would do. Okay? So, but any other time, if it means something else, it has to say that. Okay, so what about part E here? What's the probability that we win 3 or more times? What does that mean? Upwards from what?
Sorry, what?
Upwards from what?
Well, you have 5 trials, right?
Mm-hmm.
So, win 3, 4, or 5 times.
All right. Yeah. So it means win 3 times. Yep. Win 4 times. Or 5 times. So winning 3 more times, with our 5 trials, Matt, right? 3 times, 4 times, or 5 times. So what would our next step be? We're going to figure this out. Or doesn't mean to add. What are we adding?
Probability.
Okay. So where are we getting those probabilities from, Matt? Why was the last one easier? Once we knew we needed to add, why was it so easy? Where did that purple and green and red number come from?
The previous percentages.
Yeah.
Or like,
We'd already figured it out. 0 and 1 and 2 and 3. So we just, okay, well, we just need to add them. Well, what's this telling us that we need to do then? What's the next step? We would need to find the probability, right? We need to know what if R was 3, what if R was 4, what if R was 5? Because we need those numbers so we can add them. We don't have the numbers right now. So that means we got to do the problem 3 more times. Or, what's that?
Can you just add it all together?
Add what together?
The numerator with
I'm not, you mean take 3, 4, and 5 and add them together? Is that what you're saying? I'm not sure what you're saying.
I think, but you don't have those numbers.
Yeah, we would need the probability for 3, the probability for 4, and the probability for 5, so we could add them. We don't have those yet, so we'd have to find them. I didn't know if you meant actually add 3, 4, and 5. What else could we do instead? We don't want to do the problem 3 more times. So what could we do instead? I can't hear you, Claire, sorry. What's 100 minus 89.7? What's that all about? So you guys at home, Claire's saying we figured out the probability of winning at most twice. So winning 3 or 4 or 5 would be the leftovers from that. So what does winning 3 or 4 or 5 times not mean? Where Claire's headed. We win 3 or 4 or 5 times. That means we don't win 0 times. We don't win 1 time. We don't win 2 times. Okay. And we've talked about this word not already. What's that called when we use the word not with a probability? Right, Maddie? Complement. Okay. So the first day we talked about probability, we talked about the complement of a probability. If the probability of pulling a jack out of a deck of cards is 1 out of 13, the probability of not pulling a jack out of cards is 12 out of 13. And an example I said, the probability of it raining was 12.7%. What's the probability of it not raining? 80 blah, 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 point, whatever percent. Okay, so this is the complement idea. And like Claire said, that a complement is the leftovers, everything else that's there, whether you're dealing with 1, because you're talking about fractions or decimals, or you're dealing with 100 because you're talking about percents. So we can take that 100, since we're talking about percents, and subtract the number we already know, and that'll give us our complement. We don't have to do all that other work. We don't have to find 3 and 4 and 5 because we already found 0 and 1 and 2. So we can do this easier. Okay. So we get what? 10.3%. The probability of winning 3 or more times is 10.3%. So what does winning 3 or more times mean? Also, what does it not mean? What does it mean didn't happen? I won 3 or more times. I didn't win 0 times. I didn't win 1 time. I didn't win 2 times. I remember these are exact. I didn't win exactly 0 times. I didn't win exactly 1 time. I didn't win exactly 2 times. I won more than that. Right? So we can take that. This idea of a complement, right? So there's some vocab we haven't talked about for a few days. Okay? You guys didn't bring it up, but I've had students today bring up the idea of like odds. Okay? Odds and probability are not the same thing. We can't let those things mix in our head. They're so similar, though, they want to mix. Okay? So you have to be really careful about that. Okay? We are straight up talking about probabilities here. Odds are not part of this stuff. It's not binomial odds. It's binomial probability. But every probability has a complement. Okay? What's the rest of the stuff? Just like Claire said, what's the rest of the stuff? Okay? Let's look at the next example. So we got a game consisting of rolling 2 dice 10 times. Win if you roll doubles or a sum of 6. It's the probability you win 2 or more times. So Caleb, what 3 things we need to know? N, R, and P. Okay. And what's N stand for, Caleb? Okay, so what's our N value? Okay. Rolling 2 dice 10 times, 10 trials. Maria, what's R stand for? Okay, how many times you're successful? Okay, so our number of successes. So what's our R value? Okay, so it's related to the 2. It's not just 2 though. It says 2 or more, so what's that mean? Win 2 or more times, what's that mean? You also what? Yep. A whole lot of R's there, right? It's probability of winning twice, it's probability of winning 3 times, it's probability of 4 times, all the way up to winning all 10 times. And then P. Where's P come from? Where's the probability of winning once come from? Where do we look for that information? What you think? Okay, so what's that mean? We roll doubles. What's that look like? What's it look like to roll doubles? So like what? Why am I writing them down? I know what doubles looks like. I need to write that down. Why am I writing it down? So don't forget something. Yeah, make sure they're all there, right? Don't keep it all up in your head, guys. Okay, you guys are going to want to make this more visual, make it more you can see things. Okay. What about this sum of 6 business? What's that look like? How do you roll a sum of 6? Two and 4. What else? 3. What else? 1 and 5. What else? 5 and 1. Yep. What was that? Or 2. Okay. So how many ways are there to win? Why is it 10, Maddie? I don't see 10 things there.
Because you don't count 3 and 3 twice.
Right. Okay. What's that called when something shows up in both lists? Or actually, what is it not called? These events are not what? Not mutually exclusive, right? They can happen at the same time. We can roll doubles and roll a sum of 6 at the same time. Not mutually exclusive. We have something double counted. All right, so we have our 6 things that are here. We have our 5 things that are here. But one of them got counted twice. So we say, well, our 6 plus our 5 minus that 1 that got double counted gives us our 10 ways to win out of what? That's only half of a probability. All we got is one number. We need 2 numbers for a probability. 10 out of what? Where are you getting 36 from, Betty?
Because there's 6 different answers you can get on both dice, so you multiply together to get 36.
Yep. That very first thing we talked about, right? That the fundamental theorem of counting. It's 2 events. Each one has 6 choices. Multiply together to get the total number of choices. Okay? But we've used this number enough where you guys should know that by now. Only 2 dice, there's 36 ways that can happen. You know, if you roll 3 dice, that's 6 times 6 times 6. That's 216 total ways you could roll 3 dice. Okay? Not that you need to worry about that, but I'm just saying, like, figuring that out. Okay? It's just that fundamental theorem of counting. So 10 out of 36, more simply said, what, 5 out of 18? So there's our N and our P and then our whole bunch of R's. What's this telling us that we have to do? We just look at this and say, well, what's the next step? Without thinking, we just start doing. What's it telling us to do? Yeah, we got to do 9 different calculations, right? That's not too fun. Caleb? Yeah, we just do 0 and 1, right? What if we found 0 and 1 and then did not get that? Right? It's probably of not winning 0 times, not winning 1 time. Then we can figure out that means that's everything else. Right? Whole lot simpler to only do 2 calculations than to do 9. Okay? So we don't have to sit here and do that, but I just want you guys to see like how we can think about this to make it easier. Right? 1, what does that phrase mean? Okay? What does that actually mean? And is there a simpler way to do it? Can we find a way that's less work? Okay? That only works when you get it in those times where it says at most, at least, no more than, no fewer than. Okay? Otherwise, it's those exactly's. You're going to calculate exactly 2 or exactly 7. Okay? There's no way around those. Okay? So can you find a simpler way when it's these no more than? On 4C, so I designed this one very specifically. You know, it says no more than 1, 1. Okay, so think about what that means. No more than 1. So it'd be, you know, your R value would be 0, your R value would be 1. Okay, and then the next one says no more than 3. So that means your R would be 0, R would be 1, R would be 2, R would be 3. You don't have to do these two again because you already did them up here. They're the same problems. It's the same experiment. Okay, so you'll have to do 2 more and add them together to get the full thing here. So there's no way to short this one, just besides using the math you already did up here, just adding it to these two. So, but on the back, it's kind of where the problem is kind of like we just did. Find this. How can you use those 2 things here to help you on this one? How can you think your way through this one to make it a little bit easier so you're not doing a whole bunch of calculations? So this problem here is very much like for example 4. Okay. Anything you guys feel like you need clarified? Tiger, Victoria, you guys doing okay?